Another important case study involving introgressing genes from one species to another using hybrid breeding is the case of the American chestnut. I think most forest people are familiar with the chestnut story where prior to the 20th century, American chestnut was probably the dominant hardwood growing in eastern forests. Um, Achieved huge proportions. It was abundant. Humans and animals highly dependent on it. But then an exotic fungal pathogen was introduced from Asia, and it functionally wiped out the chestnut from eastern forests. You can still find chestnuts in the forest. This is a photograph I took in northern Georgia of a chestnut sprout. But this is probably about as big as you'll ever see them. They sprout from dead stumps, grow a little bit, and then get reinfected with the chestnut blight and get killed back. They generally don't reach reproductive size, so they're functionally extinct from the eastern forest. And there's been a lot of effort to develop American chestnut material that's resistant to the blight so that we can in some way reintroduce the chestnut into eastern forests in the United States. And one approach that's been taken is by the American Chestnut Foundation, where they start with a hybrid mating between American chestnut, which is highly vulnerable or susceptible to the blight, and Chinese chestnut, which co-evolved with the blight in Asia and is resistant to the fungus. So they cross those and they end up with a hybrid that's 50% American, 50% Chinese chestnut. They select hybrids from that generation that are half and half. Each individual has half of each genome. Find ones that are resistant, and then they take those and breed them with pure American again. Okay, so that's called a backcross. So once you do that backcross, the offspring from that mating are 3/4 American chestnut genes, 1/4 Chinese chestnut. You screen those to find individuals that are still carrying the resistant genes. You take those and you backcross them again to pure American. So you get a 7/8 American, 1/8 Chinese. Screen for resistance, backcross again to pure American, and keep doing that until you get a generation that's 15/16 American, 1/16 Chinese, but that 16th Chinese includes those resistance genes. And that generation can be reintroduced to the wild because it's almost all American, but it still retains those Chinese resistance genes. This effort with the American Chestnut Foundation is led by Dr. Jared Westbrook, who has his PhD from the University of Florida. So we're proud to claim him as a gator, and he's leading that hybrid backcross approach to generating material to repopulate eastern forests. At the same time that this has been happening, there have been efforts to identify the genes in Chinese chestnut which confer resistance, and then to transgenically move those genes into American chestnut. So that transgenic approach has also resulted in resistant material. So both of those programs operating independently have arrived at material which is close to being able to be deployed. Now, none of these are perfect. I know some of the hybrid backcross material, for instance, is highly susceptible to other fungal diseases. And certainly the transgenic material, there's some public resistance to deploying transgenic material wild into forests. But suffice it to say, there have been a lot of scientific efforts over decades to produce material that can be used to reestablish American chestnut into American forests.